Hi, everyone. Can you hear me okay? Okay, great. So first of all, I want to say that I'm really excited to be here. Especially, this is my first time being on the other side of the stage in a conference. So excited to be here. And also now I stand between you and lunch. So it's even more challenging to me. So my name is Tanat. Lokejaroenlarb. I think Ricard pronounced it nicely, but it's difficult for many. I'm currently a senior SRE at Adevinta. So if you wonder what it means that right now I'm writing more Google Docs than YAML files, basically. And in my free time, I like watching football. You can guess from my photo. My favorite football club is FC Barcelona, of course. And in my free time, when I'm not watching football, I write some blog posts about Kubernetes in Medium. So if you want to check it out, feel free. But don't worry, I will keep the QR code for the later part of the presentation. So some words about Adevinta. I think some of you might know us already. I think there are even a few of us here today. But if you are not familiar, Adevinta is a global classifieds company. So we do have a lot of digital marketplaces around the world, but mostly in Europe. So, for example, our e-commerce platform, such as Milanuncios here in Spain or Le Bon Coin in France. So we enable people to buy and sell second-hand goods online. And this promotes good shopping habits for the world because we help reducing waste and allow people to buy cheaper products. And also, we also expand to other sectors such as real estate, like we have Fotocasa and Habitat Clear here in Spain, and some other sectors like jobs that we have InfoJobs that you might know about. And some interesting numbers that I have just recently learned. So all these marketplaces combined, we have like 2.5 billion monthly visits. And in Europe, our active user is, I think, even more than TikTok, if you talk about Europe. And we are also a major tech company, so we have a lot of employees. And half of these numbers are actually talented engineers from diverse backgrounds, nationalities, including me. So we are trying to help each other building these cool marketplaces. So for today's talk, I want to walk you guys through one of the most challenging and mysterious incidents that my team and I have ever faced. So I think most of you have been there when you were trying to figure out production problem or complex problem to solve. And you spend a lot of time on it. You jump into different rabbit holes, but at the end, you couldn't find what is actually going wrong. So in this incident, it took us more than 1.5 months from the first encounter until we find a resolution. So I hope that by walking you guys through this experience, you could take away some lessons learned, either technical or non-technical. And before we start, some context. So this incident, it happened in the internal platform called Ship. So Ship is basically an internal multi-tenancy runtime platform that my team and I built internally and maintain. So Ship also hosts many of marketplaces that I mentioned earlier. And it doesn't just provide just a vanilla Kubernetes to our customer. We also provide, on top of Kubernetes, integrated logging, integrated metrics, managed certificates, and ingress. And on top of all that, we also provide a service level objectives for those services for the reliability. And some number on the scale. We are operating more than 30 Ship clusters right now in production. It spans across 4 regions in Amazon, and at peak time, we are serving more than 90,000 requests per second. And we are still expanding. We are onboarding more marketplaces on our platform. So without further ado, let's get to the story. So in a calm Friday afternoon, people were sipping coffee, relaxing, and that's usually when something happened in the horror movies, right? So something did happen. So our customer reported that they found this spike of fail requests on their services that is running in ship. Basically, it's a HTTP 500 errors that they observed. So by usual procedure, our team declared this as an incident and started to take a look. Now, I want some participation, so maybe you can guess, if you were a platform team and you were reported the same problem, what would be your first guess of what might go wrong? And you can keep that in mind, and then let's see if you get it right. But our first thought was that this could be the ingress issue, basically because it is related to traffic. And in ship, we provide traffic for our user using Nginx ingress controllers. So we took a look at ingress. And actually, we already have a lot of alert around how ingress behave inside the clusters. So we should have been notified already if something go wrong, but we didn't. So we took a look a bit deeper, and we found that our ingress controllers got rescaled from the traffic. So we found this fluctuation in the number of instances of ingresses. And actually, this is normal, because we have set up a thing called horizontal pod autoscaler. I think you might have heard of it. And we scale traffic based on requests per second that we have. So if the traffic fluctuates, we scale ingress controllers accordingly. And we actually found the traffic got fluctuated. So this is normal. Then what is wrong, right? So what actually was wrong, or we thought that it was wrong, is that during the downscaling of the ingress controller pods, so during the termination of the pods, it might have terminated the in-flight request that the pod is serving as well. So we thought that this behavior in turn returned 500 errors to the client that calls. So that is our guess. Then what could we do about it? So the on-call at that time decided to increase the minimum number of replica of the ingress controllers. And this is to ensure that we match with the peak time of the ingress controller pod that served with the highest traffic. So this is to ensure that there will be no downscaling event in the weekend to come. And also, we throw some money at the problem because we can. So we throw some CPU, memory, hoping that it will be more stable. And the situation seemed to be mitigated. So the customer reported that they don't see the error anymore. And we were glad because it looked like we fixed it easily, right? Of course, it didn't fix the issue. Otherwise, there will be a very, very short talk here. On the next Monday, the customer reported again that they still see their service reporting the same error. So we might miss something here. So we checked again the previous thing that we fixed, and we didn't see the fluctuation anymore. Also, there is no CPU throttling, there is no performance problem. So we didn't catch the issue. The issue must be something else. And now I think you can try to guess the next one. But for us, we thought that it could be a network issue this time. And you might wonder why we thought that it was a network issue. So let me explain. So basically, around that time, we were reported, or we were bothering by this mysterious internal alert. The alert told us that FluentBit instance is not processing any log in a machine inside the cluster. And if you are not familiar, FluentBit is a tool that is used to collect and process container logs inside a machine. And now you might even wonder more why the issue related to log would mean network issue and would mean some problem on the traffic of the customer. So let's see. So the error, what it meant to say was that the FluentBit agent that is running inside each node of the cluster, collecting logs, and after it collects the logs, it will try to forward those logs to another component is called FluentD. And it is a tool used for processing and forwarding log again to the cloud solution that we have. So the error want to say that when the FluentBit get all the logs, it have to connect to the FluentD to send those logs. And somehow there is some network error happen here that the FluentBit cannot forward those logs. So it started to pile up and overflow and stop processing more logs. So that's actually what the error meant to say. And also, in addition to that, we also have a tool that is used to monitor network connectivity inside the Kubernetes cluster. And this tool will expose some kind of useful metrics around how the networking is behaving. And we found this error metrics, saying that one of the nodes of the cluster, it failed to connect to other nodes inside the clusters. So if you can see in the red box here, on the left-hand side, it's all the same node. So this node has some problem, and it cannot connect to other nodes. And this is some kind of a sign of a network misconfiguration inside the cluster. And guess what? Coincidentally, the FluentBit agent that report the error run in this node. And also, guess what? The customer service that report the error was also in this node. So we thought that this makes sense. So the issue must be the network. How did we mitigate it? So since it's the network issue, and we have this metric saying that the node cannot connect to each other, we put some kind of a network automation so that we ensure that we always have the up-to-date network configuration in all the nodes. And again, the situation seemed to be mitigated. We didn't see the error metrics anymore about the network. Also, the customers said that they didn't see the issue also. So this time, we are quite confident because it's quite a complex issue to be found, and we found it. But again, it wasn't the issue. So the customers still reported that they found an issue again after the day. So we were quite frustrating at this point because we tried several things. It didn't work out. And at this point, our team think that this is serious because it has been 2 or 3 weeks after the customer reported the error. But we couldn't find what is wrong. And it started to impact the trust between us and customer because basically every time they report the error again after that, what we could do was always saying that we were taking a look, and then we cannot give them more answer. And also, I think it impacted the team morale because I also remember that I was also on call at the time, and I couldn't focus on anything else. I couldn't focus on my tasks. I couldn't focus on delivering value because the issue happened, and you have to look at the issue, looking at different things, but cannot find what it is. And I think I cannot even sleep well because there is this frustrating feeling that the issue might happen again any time of the day. So it's bad. But I think what is good in this is that at least our team is quite supportive. So we don't blame each other. We were together. We were trying to find the problems, and we don't give up. So we decided to dedicate more time and effort on this issue, trying to put an end to it, basically. So the next idea, what did we do about it? So we decided to create this big dashboard, having a lot of information in it. So the intention of this dashboard is that we wanted to find correlations between when the error happened, what are the other part of the system that react to it in order to find what are the components that make this error. So of course, we have the 500 errors, which is the main issue as a main indicator here. Also, we have error metrics from other such as assumptions that we have. So ingress metrics, network error metrics. Also, we put some number around number of pod and node at one time, and some API server metrics as well. So we live with this dashboard for a week, trying to find what might happen when the error showed. And do you think this is helpful? Actually, it turns out to be a pretty bad idea, and let me tell you why. So this information, it looks like it's useful, but actually, when you have this too many information, what it does is that it creates a lot of theories for you. And a lot of theories boil down to one thing, which is distraction. So let me give you one example. So one day, we were looking at the error, and we saw a number of pods and nodes going up at the same time. So our thought was that, OK, this is the issue. So we took a look, and we found a cron job that ran inside the cluster every evening. So we was like, OK, this cron job must be it. So we took a look at the cron job. And while trying to make sense of this, what this cron job does, the next day, the error happened again. But when we look at the time, it's not the same time as the cron job runs. So we were spending time on random things that is not pointing us to the problem. So it's all distractions. So we have to find other ways to tackle this. This dashboard is not helping us moving forward. So a quick summary. So we look at ingress and network. They were not the issue. We decided to create this big dashboard to help us, but at the end, it was a distraction. And what could we do now? So we decided to change the perspective a little bit. So before this, we were focusing on system metrics, how our system behaves when the error happened, what are the system behavior during the time. But actually, we never took a look at what are the services that got affected a lot. What are the main services that reported the problems? And I think for us, this is quite a game changer, this methodology. Because when we take a look at the affected service, actually, there is only one service or two services that reported most of the problem, most of the 500s. And interestingly, this service is a proxy service. So this service acts like an API gateway where it receives the traffic from the request from the client. It tries to call different microservices behind it, and then collect the response and then respond back. But the interesting part is not how it behaves, but what does the service call each other by? So the interesting part is that the proxy service, it calls to the microservices behind it using Kubernetes DNS resolution. So for example, it calls to service B inside the same namespace using HTTP-B. Or it calls to service C using HTTP-C. And that's it. That's what it does for the domain. So I think some of you might know now where I'm going. And another information to help with this is that, as I explained earlier, in SHIP, we provide different service level objectives for our user. And DNS is one of the service level objectives that we provide. And one of the service level indicators for the DNS is DNS latency, how fast we respond to the DNS queries. And when we looked at the DNS latency, SLI, of this cluster, we found that it has been way below the good threshold that we have set up. And actually, it has been like this even before the incident happened. But the thing is that it has been always like this, so we kind of neglected. We didn't take action on it. And it's business as usual, so we didn't take a look before. So the problem is shown right in our face, but we didn't know before. So with these two information, we thought that this must be the DNS issue. And congratulations, if you guessed it right in the beginning, this is actually a DNS issue. And let me try to explain what is wrong with it and how did we fix it. So first, when we thought that it was a DNS issue, we started to look at different DNS components inside the cluster. And the first component we took a look is called DNS mask. So DNS mask is used as a local cache inside each node. So it is used to cache DNS responses when it does the queries. And when we took a look at DNS mask, we took a look at its log, and we found this straightforward logs telling us that we have reached a maximum number of concurrent queries. So straightforward, right? We hit some kind of a limit. So the mitigation for this that we tried is we increase the limit. So we decided to increase the limit from 150 to 1,500 concurrent DNS queries based on some Google recommendation that we found. And let's see if it's helpful. Yes, it was kind of helpful because we can see clearly that the DNS latency SLI improved right after we applied the patch. And we were like, OK, good, we found the issue. But however, after a week, it started to degrade back to the problematic point. So the trend is not looking good, right? We bumped it back to good, and then it started to degrade. So this graph doesn't look good at all. So we found one factor, but we didn't find the whole problems. So we took a look more, and we found the next problem. We have this DNS at the server level, at the cluster level, which is core DNS. And we found that with our current core DNS configuration, we miss this small header on the response that core DNS sent back to the node local cache. So this small header, which is recursion available, when you miss to set it back to the response, basically it means that it instructs the node local to not cache your internal queries at all. So basically, we were not caching any internal queries at that time. So what could we do? It's also straightforward. We missed a header, so we added the header back. And the SLI improved again. So you can see on the 20th, we have another spike of DNS latency SLI. And this time, not only the SLI improved, also we have this internal metrics about the node local cache, cache hit, and cache miss metrics. So on the left-hand side, you can see that the cache hit rate increased a lot. So it has this drastic improvement. And on the same line, on the right-hand side, the DNS cache misses dropped significantly because now our cache started to be effective. So it looked like we found a good solution here, and we have the good indicator that we have fixed it. We fixed the issue, right? But once again, I think it was becoming our OCD at that time because the issue was with us for a month. So every day we started to open the Grafana dashboard and looking at this SLI. And after a week, we found this drop again, degradation happened again. So we found two big contributions to the problems, but we still missed the root cause. So we decided to dig as deep as possible this time. So there is a tool called DNS Tops, which is used to monitor or get the result of how many, what are the queries, DNS queries, that is being queried inside a machine. So we decided to run DNS Top selectively in a few nodes of our clusters. And the result is quite interesting. So if you can see here, I think around 70% of the total DNS queries are unresolvable domains. So for example, grafana.net.eu-west1.compute.internal, that is not going to resolve to anything. So we were having a lot of these unresolvable domains happening inside the node. And it has been flooding our DNS architecture or flooding a few limits that we have. So this is the main villain, and let's see who this really is. I think some of you might know already, but actually this is a famous issue called ndots issue in Kubernetes DNS resolution. So if you are not familiar, let me explain quickly. So ndots is a mechanism in Kubernetes DNS resolution. So if you have a pod inside a Kubernetes cluster, and your pod is trying to resolve a query or resolve a domain, and if that domain has less than n dots, and by default is 5 dots, for example, grafana.net has only 1 dot. What Kubernetes will do with that query is that it will try to append this domain inside the search configuration at the end of your domain. And it will try to append it one by one and try to resolve until it cannot resolve any of this combination. Then it will forward your DNS queries to the upstream DNS. So you started to see the problem, right? That if your cluster has a lot of external domain to query, for example, grafana.net, or I don't know, Slack or anything, it will create a lot of unresolvable domains generation inside the DNS architecture and started to flood your DNS systems. So how did we fix it? First, we tried to drop those domains because they were flooding our DNS, right? So we introduced this configuration inside our node local configuration, which is the DNS mesh. So the idea here is that we don't want this domain or this combination to reach into the higher level of DNS architecture. So we catch it at the node level, and then we drop them. So the configuration has the combination of domain that don't resolve, basically. And another thing is, we also try to use fully qualified domain name when possible. So as I explained earlier, n dots work when you have domain name that has less than 5 dots. So we try to use the fully qualified domain name that will allow your queries to not subject to the n dots mechanism. So for example, this is a bit of Easter egg. If you see the domain here is ship log router, which is a FluentD. So earlier, I explained that we have a network problem with FluentBit cannot connect to the FluentD, right? And actually, FluentBit was also trying to connect to FluentD using Kubernetes DNS resolution. So it just called to the service name of the FluentD. So it also generates a few domains from the queries. So we try to use the fully qualified domain name when possible, which will help us reduce number of total queries that being used. So let's see what was the impact. First, we saw the drastic improvement on the cache hit rates. So this is the hit and miss ratio per clusters. So I have zoomed in a bit. Yes. So you could see that after we apply the configuration change, we have way better cache hit rate inside the cluster from the change. And this is because we don't have that many cache miss anymore, because those misses domain are not being sent to core DNS. And secondly, we could see that in the core DNS metrics, the number of total requests being sent to it dropped significantly from 5,000 requests per second to around 1,000 or less. So we are onto something here. And lastly, our DNS latency SLI was back to the good threshold. And it has been staying like this until now. So I think by seeing these three improvements, we are quite confident that we fixed it. And actually, we did fix it now. There is no but anymore. So we eventually find our main villain, and we fix the issue. So now let's take some time to look at what did we learn from the incident. The first thing that I want to mention is that SLIs are super important. So having SLI that don't work well, or SLI that are flaky, it will eventually make it difficult to be trusted. And also having SLI that keeps failing forever, and you don't take any action on it, you will eventually ignore them, and it becomes just a noise. And you will eventually silence it or ignore it totally, like what we used to do with our DNS latency SLIs. But SLIs are very important in this case, especially when you want to find the problem that is this complex, that is mysterious. SLIs point into the face of the enemy, right? It shows you right away that it is DNS. So SLIs are one of the best tools to help you discover production problem. And in addition, SLIs are also used to create SLOs, or service level objectives, which is basically a contract between you and your customer. So if you have a strong or solid SLIs, you will have a better trust on you and your customer because your SLO will be trustable. And second learning is that organize the investigation. So jumping into the incident, investigation without any plan will eventually derail you or waste you a lot of time. So I want to mention my technical lead, Fabian. So he taught me this, I think, 2 years ago, and I still remember it now. So he taught me that during the incident investigation, you have to focus on one theory at a time. And you try your best to disprove it, dismiss that, use anything that you have to prove that that theory is wrong until you move on to the next theory. And this systematic approach, it will allow you to focus on fixing the issue and prevent you from being distracted and being dragged away from fighting the real problem. And I think also some bonus point on the organizing the investigation. I think it's really important that you have a shared document or a single document about the incident. We have it internally. It's called living incident document. So this document is used to collect any evidence, data point, or theory that you have tried or you will try. And this document will help you and your team staying on the same page. So if you were going to rest, your team can pick up whenever they want and pick up from where you left off. And all the information will be in there. And lastly, use data and dig deep. So I think sometimes it's good that you trust your instinct when you are trying to find a problem. So you rely on your experience, it's good. But if a few trials of the effort and you still couldn't make it, I think it's time to pivot and try to use more data to support one theory at a time and rely more on data, but not your experience anymore after a few trials. And use data and dig deep. For example, if we have run the DNS top earlier, maybe we catch the issue faster than it's supposed to be. And I think that's the summary. So today I have walked you guys through the story of our incident, how we discovered the problems, how we came up with the different solutions, but at the end, the problems keeps coming back. But we still keep pushing hard to try to fix it. So apart from those technical learnings, I think what I took away from this is that it's good to have a supportive team in this case, especially in this tough time or this tough incident. So if you have a supportive team who are not blameful, who are always be there with you when you were trying to solve it, who are not giving up, I think with this attitude, you could solve any problems that you will find in the future. And I think that's it. Feel free to come to our booth if you want to learn more about this incident or other incidents that we have. And thank you so much for listening.
Yeah, we have some questions, not so many, but let's give it a go. So first of all, let's talk about the human aspect. Was there a lot of pressure from management? How did your team deal with all this during the investigation? Because probably it took a while to find out. So, hey guys, how are you doing? Constant asking, how was the relationship with management?
So in the beginning, everything is okay, right? Business as usual. We have a lot of incidents, and we were fighting it with our own time. But I think at some point, I think management come in, but not whipping us, but remind us that we have to fix the issue for our customer. But they are supportive, so I don't think that they blame or anything. They try to bring us to the point that we know that it's important to fix it.
Lucky you. Yeah. Okay, so some people are asking, why did it only happen in one cluster? Because presumably you have some sort of automation to build this cluster, so why it happened only in one?
So that's a very good question. So basically, I think I have a graph, but I didn't bring it here. But actually, this issue happened in all clusters.
Okay. Okay.
But this cluster has the most user of Kubernetes DNS resolution.
Okay.
So it's more obvious in this cluster. And then when we apply this change, it fixed this in all clusters. So yeah.
Okay, so it's not that it only was happening in one cluster. Okay.
Yep.
So yeah, they're asking why is so much complexity on DNS if you consider moving to a managed solution, which is yet another point of failure, I guess.
Yeah. So I think we were getting better at DNS after this. So I think at this point we are able to manage it. So.
Yeah, and also the latency. So yeah.
Yep.
Yeah, I think. They're asking if you use any particular service mesh solutions for your clusters that you can discuss here.
Not at the moment. We are considering, but in general we haven't used it.
All right. And let me see. Yeah, they're asking if this could be, if in your opinion, this could be, I don't know, maybe find out before if you were doing more stress testing maybe, or how could you have envisioned that before, if you have anything, thoughts on that?
So I think this boils down to the point that SLIs are important. So if we have trust our SLI before, it would be easier. And actually, this incident reminds us of how important it is. So we started to create a lot of alerts around when SLIs are broken, like short window, long window, and we have alerts now around SLI improvement or SLI performance.
And what is actually showing up in application logs, or and they were not seen because there were so many logs, or what was the reason for not seeing this before? Well, I mean, obviously, right? Yeah.
So I think I remember that the error was 500 from the end as well. So they were we cannot connect to this service. And that's it, yeah.
Okay, I think this covers all. So thank you very much, Tanat. And we'll see you folks after lunch. Have a nice lunch and see you later. Thank you very much,
Thank you, guys.
everyone.